Good morning and welcome. My name's Stuart Kent. I'm a Group Program Manager in Developer Tools at Microsoft. I'm responsible for a number of areas, including the team indicators in Code Lens, which you may have missed the announcement that it's been moved down to Pro for VS 2015. I'm responsible for feature that's in technical preview, in sort of private preview, I guess, limited preview in VSO called Code Search. So if you have Git repos in accounts in VSO, you can get invited to actually join into the preview. And I'm also responsible for the architecture tools in Visual Studio. But I'm not going to talk about any of that today. What we're going to talk about is technical debt and understanding, preventing, managing, controlling technical debt. Now, actually, there is a relationship with architecture tools here, because we've been thinking, where should we take the architecture tools? What should we do with them? We've made some improvements in 2015 to make the code map much better for analyzing your architecture and dependencies and so on. But what we realized is that architectural analysis, dependency analysis, is just one facet of the broader problem of controlling your technical debt and managing your technical debt. You know, tangled dependencies is one contributing factor to technical debt. So we've taken a step back. We've looked at that problem of technical debt. And you'll see in the title, which I apologize, I must have been on a bad day when I wrote that title. It's rather long. Note to self, shorter title next time. But essentially, it's technical debt with the Microsoft Stack and SonarQube. And we'll get into what SonarQube is a little more a bit later. So I'll give you just 5 seconds to take that, or you can do it at the end. Okay, just please remind you that we really want your feedback. Please give your feedback on the session at the end. So we're going to start by talking about the overall problem of technical debt. And once we've gone through that, we'll give you a demo, quite a deep demo, of SonarQube and what that tool is and why it's so popular in this area. And then we'll show the work that we've been doing, collaborating with SonarSource, on actually getting much better integration between SonarQube and TFS for basically monitoring technical debt in your .NET apps. Okay? And once we've done that, we'll then conclude with just a little insight into some of the future backlog items that we've got. So this is the start of a collaboration. It's not the end of it. Okay. So what is technical debt? This chart is a sort of picture of a mythical team who might be starting off in sprint 1, so S1, these are sprints, building features, building a new product. And they start in sprint 1 only doing productive work, doing new features. But as they do so, debt starts to creep into their code. Poor design, bad coding practices, that kind of stuff. And so they start to accrue debt, which is the red bar at the bottom. And debt makes them go slower, which means instead of spending all their time on productively writing features, increasingly they spend time on having to get around the debt that's in their code, all right, or paying back the debt. And that's the stuff in yellow. So the interest, the analogy is the yellow is either paying back the principal or paying back the interest, until it gets to a point in sprint 9 where the only thing they do is pay back the principal because there's so much debt in there that they can't make any further progress. Okay. So the problem is how do we deal with that? Can we provide any tools, services, and so on that can help deal with that problem and help development teams get a lid on that problem? So we had customers back in November, well, before then, but we've had a bunch of customers. We keep talking to them at various meetings, and they're telling us this is a problem, okay? Technical debt is a problem, and they want us to provide some solutions to help them solve it. And then nearly in the next breath, they tell us, and by the way, over in that Java community over there, there's this thing called SonarQube, which is getting fantastic adoption for this problem. And even worse, it doesn't work well with your stuff. Okay. So that got us thinking. But I'm not going to carry on with that story now. You'll have to wait till further on in the presentation. What I'd like to do is welcome Olivier Gaudin, who is the CEO for SonarSource. We've been partnering with them since, I guess, January, and the result is what we're going to show you today. And he's now going to take you a deeper dive into his perspective on technical debt and actually give you a really good demo of SonarQube and how they use it in their company. So, Olivier.
Thank you very much, Stuart. So, indeed, that's so I'm Olivier Gaudin, and I'm the CEO of SonarSource. And SonarSource is a Swiss company that promotes and develops SonarQube. And I'm going to do really two things today. I'm going to explain how we feel we can manage technical debt easily, and I'm going to do a demo of it straight after, before continuing Stuart's story. So what you see on screen at the moment is really the consequences on a day-to-day basis of not managing technical debt from the beginning. What I'm going to show now is another view of what you will see on a daily basis, which is the place you really want to be is more on the left-hand side, where it seems to be going okay. And by the way, I'm sure you will guess, but here the guy might be reading his own code. Simply just wrote it like 3 or 6 months ago. I think it all happened. It happened to all of us. So this is, I would say, level 0 of technical debt measurement. You know, like you just count what you hear in the office. Obviously, we try to do a little bit better than this, to be a little bit more objective about this with SonarQube. And actually, when we talk about measuring quality, actually we measure non-quality. It's much easier. And we tend to say that technical debt is created by what we call the 7 deadly sins of the developer. Do you know what those sins are? I'm sure you do. And I'm talking about code here, nothing else. Any idea? Copy-paste. Did you read our website? So copy-paste is definitely the worst of all. It's the worst of all because as soon as you start to copy-paste, well, in terms of maintainability, this is twice more work, basically. You have to do the changes twice. You are going to have the bugs twice. You are going to lack twice. You are going to have all the problems twice, basically. Any other?
Commented out code.
Yeah, commented out code. We don't classify it as one sin, but it's indeed a bad practice. You don't want to comment out code. You know, you can always find this code back in your SCM. You don't need to keep it in the middle. So, oops, I don't want to unveil all of this. So the next one is we say complexity. So it's not about complexity as such, which is that if you have a lot of business logic in your code, you need to have complexity. You know, like you will add up a lot of complexity in your software. What we are talking about here is the distribution of this complexity, which is you don't want to have methods with one method with like, I don't know, 30 ifs, tries, catches, etc., which means that when you need to change it, you need like half a day to understand what it's doing, and then you are gonna, you're gonna be a little bit nervous when you push back your code because you don't really know if there are gonna be no side effect. Next one is about spaghetti design. So this one, it's about modularity, not having cycles between modules, for example. And it never comes at the beginning, the spaghetti design. It always comes after a little while when we start to do some changes, but you forget to do certain refactoring. Next one is very important, lack of unit test. And by the way, you shouldn't be touching any other scene without having unit tests on this. Otherwise, you are going to be in potentially difficult situation. So we fully integrate, for us, the unit tests are really part of the code, so they belong to those deadly sins. Next one is coding standards. So here we talk about style, of course, but not only. But style is important already. If every time you open a file, you are wondering, what am I going to find here? How is it going to be like? What's going to be the style? You waste time every time, and it makes it more difficult to read. But it's also about best practices. So I think I can reveal a secret here. I'm not really a .NET guy, so I can't give you .NET examples. But on the Java side, if some of you are familiar, it would be for things, for example, like if you redefine an equals method, you also need to redefine the hash method associated. OK, that's fine. Potential bug is the sixth one. And the last one is we don't say lack of documentation. Usually we say we should have more documentation, etc. What we are saying is that too much or too little documentation is a problem. Why too much? If you have too much documentation, too many comments in your code, this is a problem for several reasons. One is this is a little bit suspect. Why do you need so many comments? Is your code not descriptive enough, self-descriptive enough? The second thing for which it's a problem is that you read code, you read comment, you read code, you read comment, and it's very difficult to follow basically the code, this is the only thing which matters, really. And the last thing is, when you put comments in your code, you then have to maintain them. Like nothing worse than an outdated comment. You think you know what it's doing by reading the comment, and then suddenly you realize someone forgot to update the comment. You waste a lot of time. Unit tests can be used to do comments. Instead of putting comments, you do unit tests. The big advantage of unit tests is that when you change the code, when the behavior of the code is going to change, then you are going to be forced to change the unit test. The comment, it's not going to complain. So those are the 7 deadly sins of the developer. Those sins, they generate technical debt, and we are going to want to track this technical debt. So what happens generally when you want to start to track this technical debt in your company? This is pretty hard. We get a lot of feedback from customers or from community users that implementing SonarQube is complex overall and expensive. And this is a problem, like code review, auditing code, etc. is not the most sexy thing in the world. Like it's not very fancy technology. So if you add on to that it's complex and expensive, well, the chance that you are going to do something about it is very low. There is not going to be really someone to put traction on this. Why is it hard? There are a couple of challenges that you hit when you want to do that. So traditionally, what happens is you have like the developer who develops, they then say it's ready to ship to production. And you have the QA team, which enters the game. They look at, the quality of what we call the internal quality of what's being delivered. They review, they do an action plan, they send it back to the developers, and the developers, of course, say, thank you very much for all this good feedback. I'm going to jump on it, and I'm going to fix it. Not exactly what happens. The developer is going to say, well, you checked a version of the code which is outdated already. You should check it directly from the SCM. And by the way, I will work on this as soon as I'm finished with this very, very interesting and important functionality for the business. So basically, lots of ways to push back. Also, it comes very late. Like if someone finds something really problematic, well, everybody is ready to press the button to push it to production. So there is a big chance that you are going to end up with, we will fix it later. And by the way, I'm not saying it happens to others. At SonarSource, if we take 4 years ago, there were 3 of us, the 3 founders of the company. And we started to put a process around technical debt. Of course, we had to eat our own dog food. And every single time with the same problem over and over again, between 3 people, it was like we were pushing to the next release. So we started to realize that there was a problem with the approach. And one of the consequences is that there is a lack of ownership. You know, who owns quality in such an organization? Development or QA? Both, none, probably one of the 2 answers. So basically a clear lack of ownership. The other thing which is a problem is the requirements. How do we make the requirements consistent? I'm going to take an example. Let's ask an easy question. Who is not familiar with unit test, coverage by unit test? No one. Excellent. Who doesn't have adopted a practice of unit tests in his company? A few hands. Cool. Okay, for all the other ones, how do you measure if you are doing good? Code coverage, exactly. So basically, you know, and I know you are going to tell me, well, it's not because you have a big code coverage that you are doing good tests. It's entirely right. But if you don't have any coverage, you're sure, absolutely sure that you don't have unit tests. So let's start with the first step. How much coverage do your application need to be able to ship to production? What's the threshold you have? Not generated. 75. So in your company, is it large company, small company? Pretty big. If an application doesn't have 75% of code coverage, it doesn't go to production. It's supposed to, okay. Right, okay, so we are getting there. So basically, let's put it this way. In pretty large company, it will depend. The threshold will depend on the application. Legacy project, it's okay. It can go, 3-4 years project, can go with 20%. But on all the new projects, we're going to say it's 75, 70, 80. It's going to be super strict. Here we have a web application. Well, for web application, it might be a little bit more difficult. So let's reduce it to 45%. So basically, you end up with negotiating. Basically, each project manager or each PO or team leader will go to the QA guy and will start a negotiation, which is really, really bad. There are 2 things that will kill code quality management process. One is negotiation. If you let the door open to negotiation, this is going to be a problem. And the second one is false positive. All the noise that can come into the process is going to be a problem. So noise being, you are all going to use SonarQube, so no question about the tool. So you use SonarQube, and SonarQube has a little bug. It happens even for SonarQube, which makes that you have like few violations or sometimes hundreds of violations that are generated, and you have nothing to do with those. That can be one aspect. The other aspect can be you activate some rules in your quality profile which are not really relevant for all projects. So for the project, it's not relevant for, this is going to be noise. Those 2 things will kill your process. So the last point here is it's very difficult to enforce a quality gate. Quality gate being what is going to be the list of criteria you are going to review in order to be able to ship to production. You absolutely need to enforce such a process to say, we are really using SonarQube. You need a quality gate at the end. You need something that tells go, no go. We think we can change, and we provide out of the box with SonarQube, we can change this game. The very, very first thing is that development team should own quality. There is no question about it. If you develop a feature and you send it to the business or to the PO for review or for testing, and it doesn't work, what's the guy going to do? He sends it back to you, he says, well, you have to fix it. If you develop something, you push it to your SCM, to the SCM, and it doesn't meet the quality gate, well, it should go back to you and say, it doesn't meet the internal quality criteria. The feedback loop should be shorter. This is very important. I'm sure you are all super familiar with continuous integration, whereby you know immediately, you know almost in real time whether your master branch or your other feature branch, they build or they don't build. And if they don't build, the most urgent thing, the most important thing is to get them to build. Similar thing for continuous inspection, as we call it, which is that as soon as you inject defect, quality defect, you should have information. Then you fix it just now or a little bit later is another problem. In most cases, you will fix it now. But you should get the information very quickly. This is super important. The quality gate should be unified, which is you need to have a set of criteria that are going to be identical for all projects, you know, young developers, more senior developers, JavaScript, Java, COBOL, if you write any, .NET, of course. And the cost should be non-significant. You don't want to need to ask for a budget to put a quality process in place. If you need that, next change of manager, next, you know, storm in whatever, it's going to disappear. It has to be built in the process, basically. And then, well, maybe it's going to be more fun. I still don't think it's the most sexiest area in the world, but I think it's going to be more fun because this is really going to be something to help doing better development. Right, so how do we do that? It's actually very simple. You have to fix the leak. The very first thing you have to do is fix the leak. What do I mean by this? When you have a water leak at home, what do you do? The first thing you do, you plug the leak, or do you clean the water which has already gone on the floor? Same. You fix the leak. You make sure there is no more water going onto the floor. Why? Because if you don't do that, it's useless. It's only a matter of time before you're going to be back in the same state. Code quality? Sorry? Absolutely. Absolutely.
Stopping the flow of water and fixing the leak are two different things.
You're right. You're right. Okay. Okay. But let's come back just to code quality. Okay, code quality, very simple. You liked our presentation. You go out, you download SonarQube, you unzip it, you start it, you analyze your project, and you're going to see 10,000 days of technical debt. Where do I start? You know, I would say don't start on anything. You know, like the first thing you need to do is put the new code under control. This is really what you need to do. Put the new stuff, you know, anything you change, anything you add, it has to be this level of quality, the level of quality that you define. The rest, forget it for now. I'm not saying you should completely forget it. Still, your application doesn't have good quality, but the thing you want to focus on is the new stuff. And if you do that, this actually is sufficient as an approach to code quality. Why? Because, you know, in any company, you are going to change a lot of code each year. You know, like big companies, they claim 15 to 20% of their code base gets changed every year. If you put those 15 to 20% under control, after a couple of years, you are going to be in a much better position already. Right. So a few numbers. As you mentioned, it's a pretty popular tool. More than 50,000 live instances in the world. There was some stats we got from Rebel Labs that 50% of Java developers use it daily. That was 50% of the Java developers interviewed by Rebel Labs, I think. I'm not sure it was all of them. We cover more than 20 languages, and SonarQube is a platform plugin. It has a platform plugin architecture, which makes it good to have a good dynamic of development. Okay, now I'm going to switch. I'm going to switch to a quick demo. Okay, so what I'm going to show you is our own internal instance of SonarQube at SonarSource. So here, this is the instance we use on a daily basis. So we use it for three things. One is the developers, they manage technical debt. The second thing is I do demos in conferences or to customers with it. Very good for that. And the third thing is we use it as a laboratory to test our own stuff. So if you look here, you have the version of the SonarQube we use on this instance. It doesn't exist. The last one is 5.1. Here you can see it's 5 to milestone 10. So we deploy on this very regularly, like 2-3 times a week, what we have in our master, which of course explains why we have such gaps, you know, very high, very low, because we do a lot of testing. That's the only reason, trust me. So I'm gonna do a quick demo of this. I'm gonna show you the main features on, especially the ones that enables you to manage code quality as a water leak. So this is the homepage of SonarQube. On this, you can pretty much customize what you want. And SonarQube is like a big radiator, which collects a lot of information about projects, about many metrics about project. It also collects information about, we have the ability to collect about group of projects, like here. You know, we are interested to follow our project, but we are also interested to see how our teams are doing. We collect also information about developers. This is optional, just saying, in case you're scared. So basically, we try to provide the developers with what we call a developer cockpit, which is their own dashboard. And then you have the ability to report that. You can report it throughout time, because we record all analysis which is done during the lifetime of the application. You can report it as a table list, as a bar chart, donuts chart, tree map. I like the tree map very much because it also enables you to drill down and get a breakdown of exactly what's happening. So here, I'm very interested to know how we are doing in terms of coverage on our API. It looks like we are not doing so well on certain files. And the nice thing about SonarQube is any number you are going to see, you will always be able to click on it to get to drill down, get a breakdown of what's underlying, because one thing you need to remember, one of the things, it's not the only one you should take away from this session, but one of the things is every time you see a good metric, you should challenge it. Every time. If you see a bad metric, no need to challenge it, you need to fix it. But for any good metric, you should challenge it. Why? Because what we show in SonarQube, a lot of things we show in SonarQube are averages. On averages are, you know, you never know what's behind. If you take if you go to the garage and take your car and ask the guy to check the pressure of the tires, and he tells you, oh, in average it's okay. Well, maybe it's okay, maybe it's not. Maybe the front tires are overpressured, the back tires are underpressured, and it could be very dangerous. Same thing here. I'm going to show you an example, a very unfortunate example, which is, so this is SonarQube on SonarQube. Basically, that's where I say we eat our own dog food. We eat our own dog food. What do you think of 81.4% of unit test coverage? Good? Bad? Okay, challenging, exact. Okay, let's challenge. I click. What do you think of 81.4% of code coverage? So by the way, here, this is the percentage for each file, and we order in we sort it in the order which makes the most sense, which is the lowest at the top. So what do you think now of this 81.4%? There are so many classes which are 0% coverage. Well, it's not so good. The point is not to debate why. The point is just to show you that a number which was very, very good at the beginning, I mean, very good, let's say, is not actually so good. So always challenge those numbers. Now, where is the leak here? We don't see the leak. Here, what we see on this dashboard, which is a technical dashboard, we see actually the water which is already on the floor. This is your problem. This is your legacy. So not very actionable. What you want to do is you want to switch onto what we call a differential view. So here, I'm going to compare what we are developing now, which is 5.2, with what we had, what we have released last, which is 5.1. And this is where it starts to be interesting. It starts to be interesting because here, we actually get the number of issues. Great. I mean, great. Not so great, but we see it. 1,650 issues. And we actually get what happened during the current iterations. So we can see here that 101 problems were fixed, which is great. But also 141 problems were added. We have added in the current code base a new 141 problems compared to what we had. That's not so great. And the nice thing about this is that you can click on it, you get a breakdown of this, you know exactly when it was introduced, what is the status of those new problems. You can filter them by, by severity, etc., etc. So it's a very easy way to put your hands onto the leak. The other thing, if we come back to my question about code coverage that I asked earlier, the other thing is we provide, and this is actually the only thing we look at SonarSource, we provide a coverage on new code. And since 2 years now, we have switched to this metrics. It's not that we don't look at overall code coverage. We look at it as an indicator of how well we are doing, of course. But on a daily basis, the developers, they look at the coverage on new code, and their threshold is on this number. And they have 80, I think it's even 85 now on this new code. The last thing I want to show you here is quality gates. I mentioned it earlier, you don't have a code quality management process if you don't have a quality gate. So here is what we propose as a quality gate, a default quality gate when you install SonarQube. Super simple. First of all, there should be no new blocker violation since previous version. You develop, you shouldn't add any blocker problem. Second, same thing with critical. The third thing is the code coverage on the new code should be greater than X%. Here we said 80. It can be 60. This is very, very good already. And the last thing is the technical debt ratio, which I'm not going to explain now, should be A. This is, I would say, an optional criteria, but if you stick to the first 3 already, that's going to make a big difference. I mean, especially in terms of code coverage, it will make a great difference, and you will see the results very quickly. I'm going to switch back to presentation. So, oh, no.
I've done it.
OK, thanks. So what I showed you is Java. I showed you Java because I wanted to show you live data that we use for real. And we almost write only Java. We write a little bit of other things, like C#, C++, JavaScript, of course. But JavaScript was in my dashboard. But we also cover more than 20, I think it's 23 or 24 languages, amongst which C# on VB.NET. The problem is that a year ago, we released a version 3.0 of our .NET ecosystem, and we had a lot of feedback. You know, like, not all was good. I mean, actually, very little was good feedback. And the main thing that I remember from that event was that people told us, you guys, you think like Java developers. You are not in the .NET environment. You don't get it. You should hire C# developers. And this is when we reached out to Microsoft, because we thought that, well, that might be where we can get good C# developers. And it was, I think, the next day where you had this.
It's in November, yes.
Yeah,
yes.
It was in November, and it was basically the next day where they had this thing about the fact that there should be technical debt management in the Microsoft ALM.
Yes, so just picking up on that story, actually, what happened is we were at the MVP summit, and we were talking about technical debt with the MVPs. This was in November. And they were also saying, here's a quote from Marcel de Vries. Is Marcel here? No, we can't see him if he is. Anyway, a quote from Marcel, which is illustrative, which was from them saying, you need to get your act together with SonarQube, essentially. And then the next day, we got the email from Olivier saying, can you help? So at that point, we went and visited them in January. and started to collaborate to fix this problem. So, let's just take a step back and dive in a little bit more about what that problem is we're trying to fix. Because there's a sort of broader story here, and we're only on the sort of first part of that story. So you get your code quality data, code analysis issues, code metrics, clones. I don't think you talked about the clones or didn't demo that. Coverage, also things like architectural insights and possibly ALM insights, which would be things like where's your code churning? Which bits of your code are churning most and stuff like that. So, and then even application insights. Which bits of your code are being used most by the business? Okay? Which bits are churning up most errors in production? There's a whole load of other data that we can look at here. So I just want to sort of broaden your minds a little on that. And all that is going to be really overwhelming. If you just look at that raw data, okay, and you get that coming back, you'll look at it, and then never again will you touch this stuff again because there's nothing you can do about it. Which is actually an issue with code analysis. Okay, if you go and switch on code analysis in Visual Studio, you get so many errors, you switch it off again. Okay. So the first thing you do is you define the quality profile. So you choose the rules and data that are important to you. And Olivier didn't actually show that in the tool, but there is a way in SonarQube of actually defining a quality profile. And that gives you some filtering, but it's still overwhelming. There's still too much. So then there are some other things you can do. You can define a baseline. So you notice that Olivier was actually doing a diff between the previous version. And you could see how much that cut down the amount of things you need to look at. Okay. You define quality gates, so acceptable thresholds. So you saw what those were. In fact, you can have quite a small number. And then you might add to that, which they don't have at the moment, but we're talking about it, is this notion of a remediation policy, which would be, for example, don't make it worse, which is kind of, new code, change code, just clear that up. Clean up as you go would be a slightly variation on that, which would be when I touch a method, you then show all the debt in that method and you clean it up. Okay, so that would be a slight variation on that. And once you've got those filters, that gives you the issues to focus on. Okay. So now we can put that into an ALM workflow. And how do we measure the code quality data? Well, we do that on builds. So when you're doing the build, you can run code analysis and all these other things and gather that other data, okay, and send that up to SonarQube. Now, you're not going to do that every check-in, but you might, for example, I think you guys do it twice a day, don't you, at lunchtime and at night, because the code analysis and stuff is going to take more time, and you don't want every check-in to have to hit that, okay, and report that up. Then you need a way of gathering that data, some kind of data mart, and SonarQube is providing that. You need a way of understanding that data top-down and seeing it, okay, and again, SonarQube's providing that. And then you can define your controls, which we can also do in SonarQube, and then you want those controls to impact what the developer does in Visual Studio. So ideally, the developer shouldn't actually have to go and look at the dashboard very much. Ideally, what should happen is that that data, those controls, feed down into the experience so that a developer only sees the debt that they need to fix. So you don't have the problem if I switch on code analysis and suddenly I get all these errors. What I'll get is only the errors dictated by my quality gate, okay, and the baseline that I've set and the remediation policy that I've set. Now, having said that, we're not there yet, but that's on the backlog, all right. So what I'm going to focus on now is the piece that we have done around .NET and TFS, which is actually getting the integration piece between our build and SonarQube fixed, basically. So this was the issues that we had. The first was, as we dived in with Sonar Source and looked at what the problems were with the current way they were doing it, we noticed that they were basically duplicating a lot of what MS Build is trying to do, or does do very effectively. And MS Build can be quite complex, okay? So they're trying to externally reinvent some of that logic to discover stuff about which projects and things. So, for example, you had to have a solution in order for the analysis to work. It wouldn't handle solution folders. and stuff like that, okay? So the first thing was to fix that. And of course, how do you fix it? Well, you get MS Build to do the job for you. It's just that they didn't know that, so we could help them, okay? The second was there was no integration with, well, the first thing, no integration with our continuous build system with TFS, VSO, build in that. So the way we've sorted out the MS Build and also sorted out the integration of that, and I'm going to show you that. The third is that the next part of that is we got the new Roslyn-based analyzers. Have any of you seen that session, the new Roslyn-based analyzer Visual Studio 2015? Okay, so they had no way of handling that. And in fact, they were writing their own analyzers in Roslyn, but not in that framework. Okay, so Sonar fixed that. Sonar's also fixed that. They've actually rewritten their analyzers in that framework. And at the moment, we're not quite able to send, we can send the data from their analyzers, but not everybody else's. But that's getting fixed. We need the Roslyn team to be able to output the results of analyze into a particular file format. That's going to be fixed in the next couple of months or so. Okay. So when we're done, if anybody writes analyzers in that framework, we can take the results of those and send them up to SonarQube. Okay, so we get that nice integration around that ecosystem. And then the final one was the metrics. That was the thing that Marcel really pulled against, was the metrics were inconsistent. Well, we haven't fixed that because we found all these other problems when we dived in more deeply, but that one's on the backlog as well. So what I'm going to do now is give a demo, I think that's 8, isn't it, of the bits. So, good. So imagine that I'm a developer. I've gone and made some changes to this code base. The application's not important here. It's an internal app that we've been using to experiment with visualizations over TFS work items. Hence, it's called backlog maps. It's maps over a backlog. But some of the ideas are coming into the product, but I won't go any further with that. So I'm a developer. I've been making changes to my code. Okay, checked in. The build happens over lunch, say, or overnight, and it identifies some new errors. Which are those? Okay, so I've got 2 new errors coming in. So what happens next? How do we go through that flow? And I'm going to walk you through that flow. Just before I do that, I'll just tell you what the setup we have here. We've got 2 VMs in Azure. We've got one, if you imagine Olivier as one of those VMs, hosting SonarQube. So that hosts the server. And then we've got one which has TFS on it. It's installed so that TFS is also acting as that machine is also acting as the build agent. And for that, we needed to install Visual Studio on it as well. So that's the other machine. And I'm just going to use that as the Visual Studio client as well. But I guess you could divide me into 3 and have those split up as well. So if I go and look at the 2 added issues, I can see that I've got an unused local variable, and there's something else about the same line. So I've got 2 issues related to that, and I can drill in and I look at the code when that comes up. And so I can see, there's the problem. And I'm seeing that this is doing a bit of work. I know that this method is actually called quite a few times. It's called most of the time, in fact. So I don't want to be doing that work there. It's probably causing a bit of a performance issue. I know my app is running not as well as it should, so I'm quite happy to have found that issue. Okay, I need to clean that out, basically. It's not a bug. The app still works. It's still functionally correct. It's just det that's in there that I must have, what must have happened is that was in there, then I decided to rewrite this, didn't use the local variable anymore, just forgot to delete it. So now I need to go and fix that. Okay, so now here it would be nice if you could click on a button here and say, go and open in Visual Studio to fix it. We haven't got that. We've got some of the pieces to do that, and we may well do that, but at the moment we haven't got that. So I'm just going to go over to Visual Studio. I've got my code open in the solution. I've searched for that method, so I'll just double click on it. And hey presto, I see the problem. So let me just delete that line. Okay, save it. Then I can go to the Team Explorer, go to my changes, and check that in, or commit it. We're on Git here. I'll just sync those changes. So that's now gone to my TFS server. And now what I want to do is go and build that. Now, you can configure the build to be automatically build and stuff like that, and you probably put one on a timer, but I'm going to manually do it here. So if I look at the build, and I'm just going to kick off the build. So let's just do that. Right, well, that will take about 4 minutes. So while that's going on, it's like a cooking program. I'm going to flip to the presentation again and just talk you through what we've done and how this works. Okay. So we've got the SonarQube server, we've got the build agent as I described. The first thing is we have a pre-build step which goes and fetches the configuration from the SonarQube server. So actually what it's fetching is the quality profile information and the quality gates. So that's going to influence the analysis that's done during build. So if you change those profiles and quality gates, you'll change the data that gets reported up and the amount of data. Okay, so one thing we've got is we're now controlling this with the SonarQube, what you do there and specify there. Then during MS Build, the analysis is performed. And also, in addition, that's just part of normal build, in addition, we go and collect project information, okay, which before the Sonar Runner was actually calculating that itself. So we're using MS Build to calculate that and output it. So that analysis data and the solution project data goes into the file store. You then run test. That will generate code coverage data. That's just part of standard configuring the builds in TFS. And then post-test, a number of things are done. Well, the first thing is it goes to the file store to fetch all that data that came back. Okay, then it can run some additional analysis. So the Sonar Runner actually detects code clones. So it does that. It performs additional code analysis. So for example, they have a load of JavaScript rules, code analysis rules, so we perform those. Okay, we don't have any, but Sonar does, so that performs the JavaScript analysis. And it calculates the metrics. And then when that's done, that is all sent back up to SonarQube. So if I switch back to the demo, and let me just open that, the build definition, and you can see some of that here. So if I look in advanced, so you'll see that there's a pre-build script argument here and a pre-build script path. So the argument is actually defining the name of the project in SonarQube that you're sending the data to. And the pre-build script path is actually calling the runner, which we've installed on the build agent. Okay? And then if we look at the test, all right, you can see it's run the test sources matching the test, DLL test, and so on. All right. So I still see it's probably got a minute to go. I've been faster than I thought I'd be. Right, so let's have a look at one of the builds from before, so you can see the results that come out. So you see here we've added a new section into the build summary, which talks about the SonarQube analysis, okay? And there's a link there that will actually take you to the SonarQube server, which I'll just wait for that to finish and then do so you can see the det gone. If we have a look down here, go further, let's see what else there is, right? And then there's the normal stuff. Actually, I should go to the log. And then there's more detailed information that is sent to the log about all the processing and stuff that's done, including the amount of time, for example, it's sent doing the last bit after the test runner. So you see the 2 minutes and 4 seconds it's taken to finish that analysis and send the data up. Okay, so that's now completed. So if I go to the analysis results here and just open it up, and if I do my diff here since the previous analysis, you'll now see that those 2 issues were removed and taken out. Okay, so you've seen the whole loop there of the process and everything we've gone. Now, the final thing I want to show, give a demo of, is if you looked when we were looking at the plan reader here, when I had the local variable thing there was no indication in Visual Studio that there was actually an error there, that there was a code analysis error there. And that's because this is Visual Studio 2013. If I switch to now Visual Studio 2015, which is on another thing, so here we are, Visual Studio, it's actually the CTP, but 2015. If I look at that, you'll now see the same issue there. And if I hover, you'll see there's the local variable issue. And you'll see here, if I go down, that's being raised by the error. So Sonar Source have re-implemented their code analysis rules in the Roslyn code analysis framework. And you can download those. The NuGet's available. The V6 is available. And you can run them inside Visual Studio. So that's starting to fill in that other part of the piece of that workflow. Now, what you can't do is the filtering is a bit limited here. You can filter to open documents, current project, and so on. And what we're talking with the platform team, the VS platform team now, and the code analysis teams, is we're talking to them about an experience in Visual Studio which allow you to filter by a baseline. So what that will mean is I'll be able to, and then we'll connect it to SonarQube so that you can say, only show me the errors since that baseline, which was the last analysis done or the last release done by SonarQube, which will immediately cut down the amount of noise that you get inside Visual Studio. So as you can see, we're getting close now to really, really getting that noise down so the developer, this actually becomes a really productive tool to get a lid on code quality to fix that water leak. So if I go back to the presentation. So this I just put in because I thought it was interesting. This is actually some of the Roslyn code base. And when the Sonar's rules were run on it, this was one of the bugs that was found, which we reported to Roslyn, and within an hour it was checked in and fixed. This was only one that we happened to take a screenshot of. There were actually a few more others like this. But overall, actually, the quality of the Roslyn code base is pretty good. I think it has a Squirrel rating of A, so it's not so bad. Okay. So what's next? Where are we headed? So the first thing is on the build side. This will actually work with VSO if you use an on-premise build agent. Okay, there's one bug that they're just trying to fix now, which is, for some reason, we can't get hold of the code coverage data when we use the build agent. We're trying to fix that, okay? But it will work with VSO with an on-premise build agent. What we want to do is make sure the appropriate bits are installed on the cloud build agent so that you don't have to use an on-premise build agent. So in VSO, you'll be able to just go and configure a build, use the cloud build agent, and send your data up to SonarQube, okay? The next thing is, well, the first thing, I should have put that at the first, is we want the task, we want to use the new TFS VSO build, the task-based build, which I think was talked about yesterday, okay? We want to actually have tasks in there for sending data and stuff for SonarQube. And that will become rather interesting because that build system encourages you to build Java and lots of other different kinds of apps, which SonarQube can already handle. So we can actually start, you can start using our thing our system to actually build all sorts of apps and monitor technical debt across a heterogeneous set of applications, which is kind of rather interesting. We want to send the data from those new Roslyn code-based analyzers. We're sorting that out. That should happen quite quickly. I've talked about the Java builds. And then Sonar Source are going to take their runner on MS Build and integrate it with other build systems like TeamCity and so on. So if you're using TeamCity, for example, to build your .NET apps, then you can also use the same bits that we've done with MS Build to integrate Sonar quality management there. for those code analyzers, SonarSource are committing to making regular, like monthly updates to the analyzers. So they're all open sourced as well, and you'll see more and more analyzers coming to sort of match what they have in Java, which is also interesting because the Rosin framework's great, but there aren't a lot of analyzers there at the moment, so more are going to get added. And then on the IDE side, the two things, it won't be for RTM, possibly for update 1 if we can do it. We want to put in that baseline support, and we also want to fix the metrics problem. We want to make sure the metrics that are being calculated by SonarQube are the same metrics that get reported up through Visual Studio. And we're also looking at things like using CodeLens as a way of surfacing some of this data and all that kind of stuff. So I'll just give you a screenshot of the task for VSO, the TFS VSO build, so you can see an idea. So that's what I mean. If with a new build system, you can imagine having two tasks like that, which is the pre and post, and you just add them in, and then you'll get the data being sent up. So, summary. We talked about the problem of technical debt. We've talked about ways to go about it, particularly the sort of water leak metaphor. We've shown you SonarQube. We've shown you the integration. We've shown you how that can be used. We talked about what's next. So really the final thing is resources. So we've tried to keep this easy. A blog post went out. That Acker MS SonarQube integration link will take you to that blog post, and all the details are in that blog post about where you can get the bits. There's a ranger's guide about installing Sonar and installing all this bit, and it's ready to use now on TFS 2013 and VS with VS, okay. So, questions? Yes?
So you mentioned the build runner will be available at a future point for CI systems other than TFS. After that point, after you deliver that, whether that's 3 months or whatever, what will be the net set of things that a firm that doesn't use TFS will be lacking relative to those who do? The firm I work for, we have a combination of Jenkins and TeamCity for both Java and .NET, large-scale infrastructure. We're not TFS. I heard that there were also issues possibly with the IDE plugin if you're not using TFS, but what would, say, 3 to 6 months down the road, after you've delivered what you talked about, what will be the net thing that if you're not using TFS, you still won't be able to do?
Okay, so if you're not using...
or Visual Studio Online.
Yeah, okay. Well, I think providing we do that integration to those systems with the MS Build Runner and stuff like that, I would have thought the rest should work. In Visual Studio, there's no dependency in Visual Studio on the TFS and everything. So I think that's what we're trying to do, is we understand people have existing builds, they have existing systems, and we don't want to sort of preclude you guys using this for that. So. Thank you. Oh, just one other thing. We're going to be up in the ALM booth after this for a couple of hours, and Olivier has a whole bunch of T-shirts just like his in that booth. So please come and ask us questions. We can give you more detail, answer your questions more detail, and come and pick up a T-shirt. Okay, thank you.